This video will briefly introduce two methods of calculating member forces of simple truss structures. First, method of joint. Let's look at this truss structure. Suppose there is a load acting on a joint at the right end. How can we find the force induced on a member near the middle of the truss? For convenience, we name some of the joints and members. When the structure is in equilibrium, we know each single element is also in equilibrium. We can start at joint A. There are only two member forces acting on joint A, but they are perpendicular to each other. They cannot cancel each other. If any one of them is not zero, joint A cannot be in equilibrium. Therefore, S1 and S2 are both zero. Now, let's look at joint B. There are four forces acting on joint B. From the previous step, we already know S1. And, because F is given, there are two unknowns left. By using vertical and horizontal equilibrium conditions, we can find S3 and S4 by simple calculations. First, we need to resolve S3 into horizontal and vertical forces. That is, S3 times cosine 45 degree and S3 times sine 45 degree. In the vertical direction, S3 times sine 45 degree has to equal 10 Newton. That means S3 is 14.14 Newton. In the horizontal direction, S3 times cosine 45 degree plus S4 has to become 0. Then, we have S4 is 10 Newton. But it is pointing to right. After joint B, we can repeat the same procedure at joint C, joint E, until we reach the joints for member X. This requires a lot of calculations. However, we can also start from supports of the truss by considering equilibrium condition of the whole structure and taking moment about H. The moment about H is the sum of all forces times their corresponding perpendicular distance from that force to the point H. Assume the length of each square is L. The moment about H has to be 0. That means Sg times L equal to Sh times 0 plus 10 times 4L. We will get Sg is 40 Newton. As the net vertical force has to be 0 too, Sh will be 30 Newton. After finding reaction forces at the supports, we can consider joint H and apply equilibrium conditions to find member forces S1 and S2. After that, we consider joint G, and then joint I, and then joint K, until we reach joints at member X. Although we can calculate fewer joints by starting from H, this method is still time-consuming when there are many joints and members. Here, we will introduce a much faster method for finding force on members. Method of section. Actually, when a structure is in equilibrium, any part of the structure is also in equilibrium. For example, when we cut the structure into two parts, the left section part and the right part are both in equilibrium. Let's look at the right part. We have three unknown member forces, X, Y, and Z. As the right part is in equilibrium, by considering vertical equilibrium, we can find the unknown member force X easily. The sum of all vertical forces is 0. That means vertical component of X should cancel the load F. So, X is 14.14 Newton. Further, by taking moment about point E, we can find member force Y. Because the moment about point E has to be 0, that is, moment induced by Y will cancel the moment induced by F. We have Y equal 40 Newton. Then, by considering horizontal equilibrium, we also find member force Z. As the sum of all horizontal forces is 0, we already found X. Then, we can get Z equal to negative 50 Newton. That means it should point to right. Method of section is fast. Once we make the correct cut. For the same problem, if we cut the structure horizontally, Here will be too many unknowns to solve. The general trick is to cut the structure into two parts, such that there are no more than 3 unknown forces. Because we only have 3 equilibrium conditions to solve for the unknowns.